Alright guys, today we're going to go ahead and work on section 8.4, which are multiplicative inverses of matrices. And then I'm going to show you, by using the multiplicative inverses, how to solve a system once again. Alrighty? So let's first define what an inverse matrix would be. If you take A times his inverse, you would get 1. Okay? Well, let me rephrase that. You multiply A by his inverse, you would get I sub n. Okay? And I'll explain what that means in a minute. But what you're going to end up with is a matrix that has ones on a diagonal and zeros everywhere else. So let's go ahead and let's just walk through how to do that. So let's do find AB and BA and determine if they're inverse matrices. So let's say A is -1, 3, 2, -5, and B is 5, sorry, I said 5, I wrote 2, 5, 3, 2, 1. Alright, so the first thing you do is multiply A times B. So remember, we the other day used our little cards. So if you still have them and you want to use it, we're going to do row 1 by column 1. Okay, so row 1, column 1. So I'm going to multiply -1 times 5 is -5, 3 times 2 is 6. Now I'm doing row 1, column 2. And I'm going to do -1 times 3 is -3, 3 times 1 is 3. Now I'm at row 2, back to column 1. Alright, so 2 times 5 is 10. 2 times -5 is -10, and row 2, column 2, so 6 plus -5. And so when I clean this up, I get 1, 0, 0, 1. Alright, so far that looks good. So he meets the requirement. Let's do B times A. Now again, I like to just take a second and rewrite it. So I'm going to do 5, 2, Lord have mercy, I can't get that right. 5, 2, 3, 1 times -1, 2, 3, -5. Now, this time I'm going to go ahead and try not to show you all the work. Alright, so row 1, column 1. So I have -5 plus 6 is 1. 15 minus 15 is 0. -2 and 2 is 0. 6 and -5 is 1. So since both of them are this identity matrix, then they are multiplicative inverses. Alright, does that make sense? And we could do a 3 by 3. It just, again, you would have ones on the diagonal with zeros on the other. Alright, now I want to teach you how to find the multiplicative inverse of a matrix. Okay, so we're going to do this by hand. Alright, so we're going to walk you through how to write the inverse. Step 1. Find the value of 1 over AD minus BC. Alright, let's look at just a regular matrix so I can make sure we all understand that this is going to be A, B, C, and D in a regular matrix. Alright, so step 1 is to actually use the matrix to calculate this. Alright, step 2, if I could get my fingers to work today. Reverse A and D. And negate B and C. And step 4, you multiply step 1 times the new matrix. Okay? Or, if you prefer to write it, it's 1 over what you found, AD minus BC, times D negative B negative CA. Alrighty? So, either one of those works is going to get you where you want to be. Alright, so example 2. Find the multiplicative inverse of each matrix. And we're going to do, I think, 2 of these, just so that you get used to how to do them. Alright, so let's say that your first matrix is negative 1, 3, negative 2, 4. Alright, so step 1, I want you to do 1 over AD minus BC. So AD is this diagonal, BC is this diagonal. So negative 1 times 4 is negative 4, minus 3 times negative 2 is a negative 6. So that gives me 1 over negative 4 plus 6, which is 1/2. Alright, I'm going to do step 2 and step 3 together. So step 2 and step 3 say, in your original matrices, swap A and D. So that becomes 4, that becomes negative 1. And negate this diagonal. Negate just means to change its sign. So the 3 becomes negative, the 2 becomes positive. And then finally, in step 4, I want you to multiply your step 1 times this entire matrix. 4, negative 3, 2, negative 1. So you're going to take a half of each element. So a half of 4 is 2, a half of 2 is 1, a half of negative 3 is negative 3/2, and a half of negative 1 is negative 1/2. Okay, and that would be the inverse matrix of this guy. Okay, now believe it or not, we're going to do another 2 by 2. We could actually do a 3 by 3, but we're not going to play that game. Alrighty, because in reality, I'm going to show you tomorrow in class a trick to do these for your 3 by 3s. I still expect you to be able to do a 2 by 2. Alright, so let's make sure we understand that you got to learn this by hand, and then I will show you another method tomorrow. Alrighty, so here's my matrix. Step 1, and I'm going to pause and let you do this on your own. I'd like you to go ahead and do 1 over AD minus BC. Okay, and I'm just going to kind of freeze my screen for just a minute and let you go ahead and try. Alright, I got 1. I did 3 times 1 is 3, negative 2 times negative 1 is 2, 3 minus 2 is 1. Alright, so I'm going to do step 2 and step 3 together. So you're going to change A and D. So on this diagonal you flop them, you negate the others. And finally, now I know that I just multiply by what I got in step 1, which means my final answer will just stay what it is here. Alright, and that's your inverse matrix. So why do we find inverse matrix? What's the point of it? And the point of it is that, to go back to how you solve an equation for just a minute, if I gave you 3x equals 9, one way you could solve that is multiply by its inverse, correct? You could multiply both sides by 1/3 and then solve it. So theoretically, if I have a matrix, can't I multiply both sides by its inverse and thereby get me the answer? Alright, so that's what we're going to want to do in our next example. Alright, so let's put this together. I'm going to show you a couple to do by hand, and then tomorrow, again, I'll show you a different little trick. Alright, so example 3. Solve each system using inverse matrices. Alright, so let's say I have 2x plus 3y equals 6, and x plus 2y equals 5. So the first thing I want you to do is we're going to write this as a system of matrices. Okay, so the first matrix is going to be just the coefficients. So the coefficients of my terms are 2, 3, 1, and 2. So what's missing? My x's and y's. So they become part of my second matrix. And then my last matrix on the equal side are the solutions. Now what I'm going to have you do is find the inverse matrix of this one, because then if I multiply both sides by that inverse matrix, right? So if this is A and this is B, and I'm trying to find x, if I multiply it by its inverse and I multiply by its inverse, I get x is equal to the inverse. That's really what I'm doing, okay? I'm going to find his inverse and I'm going to multiply both sides by it so that I can find the value of x and y. I understand we could solve this system by elimination, we could solve it by substitution, just another method, okay? But you need to know how to do this one, in addition to all the other ones you already know. Alright, so let me recopy what I had from the other page. You don't need to recopy this, I just want to be able to work off one page. So I'm going to find the inverse of matrix A. So let me go through my little step process. So the first thing I'm going to do is figure out what is 1 over 4 minus 3. So I get 1 over 1. Okay, that goes here, which means I'm not going to change my matrix. Now, let's think. We're going to swap A and D. We're going to negate the other guys. So my new matrix is 2, -3, -1, and 2. So I'm going to take this matrix and multiply both sides by it. Now when I multiply it here, do you agree that that's going to cancel each other out? So if I do 2, -1, -3, 2, times 2, 1, 3, 2, xy equals 2, -1, -3, 2, times 6, 5. Okay, if you don't believe me, you could go ahead and multiply those. In fact, we can go ahead and do that together if you'd like, just to prove to yourself that it works. So row 1, column 1. I have 2 times 2 is 4, 4 minus 3 is 1. Row 1, column 2. 6 minus 6 is 0. -2 and 2 is 0. -3 and 4 is 1. Alright, let's just continue here. So row 1 times column 1. That gives me x, and 0y is x, and y. So it did. By multiplying a matrix by its inverse, I get what's left. So I really get rid of it. Now let's do this other side. So I want row 1, column 1. So 6 times 2 is 12. 12 minus 15. Negative 3. And now I do row 2, column 1. So negative 6 plus 10 is 4. So my answer is negative 3, 4. Right? X is equal to negative 3, Y is equal to 4, and I'm done. So again, I understand you think it's a lot of work. Realize, though, I've kind of walked you through quite a bit here. So we're going to do one more example without showing all those little itty-bitty steps. Alright, so let's solve the system 4x plus 5y equals 6, and 6x minus 7y equals a negative 20. And we're going to, again, solve it using inverse matrices. So, step 1, give me all your matrices. And I'm going to pause for just a moment and let you go ahead and fill that in. Alright, I have 4, 5, 6, negative 7, x, y, 6, negative 20. Does yours match mine? Alright, I want you to write the inverse of this matrix. So the first thing I need to do is go over to the side and do 1 over AD minus BC. So I get what? Negative 28 minus, oh good golly, this is going to be ugly, minus 30. Ugh. So I get what? 1 over negative 58? Are you kidding me? Ugh. I think we need to abandon this one. Let's start over. Hang on. Alright guys, so we're abandoning this one. So let's do another 2. Alright, I should have checked that problem before I got into it. Obviously, not all these problems are going to work out very pretty. Alrighty, so let's try number 2 again. Let's do 2x minus 2y equals 2, and x plus y equals 5. And I understand we could do this by elimination, it'd be a lot quicker, but we're learning a new practice. Tomorrow I'm going to show you why you're learning to do this by hand. Alrighty, so first things first, let's go ahead and write our stuff in terms of matrices. So 2, negative 2, 1, 1, and x and y, and 2 and 5. Okay, what I'd like you to go ahead and do is find your inverse matrices. Alright, so the first thing you're going to do is come over here and do your 1 over AD minus BC. So AD is 2 minus a negative 2 gives me 1/4. So I'm going to do 1/4 times, I swap these guys, I negate these guys. And my inverse matrix would then be 1/4, don't panic that it's fractions, 1/2, negative 1/4, and 1/2. Now I'm going to multiply both sides by that inverse matrix. So over here, this crosses out, and you're left with xy. Over here, I'm going to multiply 1/4, 1/2, negative 1/4, 1/2, times 2/5. Alright, so I'm going to do row 1, column 1. If you're panicking about the fractions, grab your calculator, it can do them for you. So 1/4 times 2 is 1/2. 1/2 times 5 is 5/2. Let's do the top. Second row, column 1. 1/4 of 2 is a negative 1/2. 1/2 of 5 is 5/2. And now I just finish it up. So 1/2 and 5/2 is 6/2, which is 3. Negative 1/2 and 5/2 is 4/2, which is 2. And over here I have x, y. So I know that x is 3 and y is 2. Okay, so my expectation is that you should be able to write a 2 by 2 matrix, the inverse, and then solve a system. And then tomorrow in class we'll go over how to solve a 3 by 3, but we're going to use the calculator. You guys have a great evening, and I'll see you tomorrow.